Hi everyone, welcome back to JDCodebase. This is the day 40 of our LeetCode 75 study plan series, and today we are solving maximum level sum of a binary tree. And the best part is we are going to use the BFS breadth first search to solve this. If you have never heard about the BFS before, don't worry at all. By the end of this video, you will completely understand how BFS work and why it is perfect for this problem. So let's get into it. And first read the problem statement together. Given the root of a binary tree, the level of its root is 1, the level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of nodes at level x is maximal. Now we are given the root of a binary tree. We have to find the level whose sum of all nodes value is maximum and return the level number, not the maximum sum. We have to return the level number here. Like I have this tree 1 7 0 7 minus 8. This one is the level 1, only this single one, and 7 and 0 at level 2, and this 7 and minus 8 is at level 3. If I make the sum of this, here sum is the 1 only because there is only one element. For level 2 sum is the 7. For level 3 sum is the minus 1. So here maximum sum is the 7 here, and this belongs to level number 2. So we have to return this 2 here, means this level here. So now the question is, how do we visit every level one by one? That's where BFS come in. So by using the BFS, we go every row by row and we calculate the maximums, we calculate the sum and track the maximum sum value and their level. So by this end of this solution, we get the max level of that has the maximum sum. So let's write the code in the LeetCode, so you understand it clearly. Here we are given a function, the maximum level sum, and we get the root of the tree as a input. So let create const qui is equal to root. Here first we create our qui and put the root inside it first. So this is where BFS always start from the root. Next is the let maximum sum is equal to 0, minus infinity. Yes, minus infinity, and I just declare a maximum sum and its value is negative minus infinity. Why? Because node value can be negative, so we cannot start with the 0. We need the smallest possible value, so any real sum beats it. Now declare the two variables, result level is equal to 1 and let current level equal to 1. Here result level store our final answer, which level has the maximum sum. So this is result level, and current level track which level we are on the right now. Both start at 1 because root is at level 1. Next we have to start a while loop. While qui dot length is greater than 0, and here we keep going as long as there are the nodes in the qui. Means when the qui is empty, we have visited every level, so we stop it when qui is empty. So let declare level sum is equal to 0 and let level length is equal to qui dot length. So for every new level we reset the level sum to 0, so we calculate the fresh, and this is the key line. Here we snapshot the qui length. Right now, before we start pushing children, this tells us exactly how many nodes belongs to the current level. So let's write a for loop for let I equal to 0, I smaller than level length, and I plus plus. Here I have to write a, means we run the loop exactly level length times, and meaning like we only process this level node, not the next level nodes, and const node is equal to qui dot shift. Then we have to do the level sum equal to node dot value. Means we pop the first node from the qui and add its value to the level sum. After that, if node dot left has any value, means any children, then we have to do one thing, qui dot push that node dot left. And if node dot right, then we have to push qui dot push node dot right value. Means if the node has a left or right child, we push them into the qui. They will be processed in the next level loop. So we check if they exist first or not. So we do not push null. And after this complete for loop, means we get the level sum. We update the maximum sum. If level sum is greater than maximum sum value, then we have to update it. Maximum sum is equal to level sum and result level is equal to current level. And means after after the for loop finish, meaning after we process all the nodes in a level of this level, we compare level sum with the maximum sum. If it is bigger, we update the maximum sum value and save this level as our answer. And we check after the loop not inside, because we need the complete level sum first. Now after this, do one thing, current level plus plus, means we move to the next level and repeat it. So in last we have to return the result level, and here is spelling mistake. Return. So yes, so let me run this solution and let me explain you one more time with the example. Yes, our solution accepted. Let's try to submit. And yes, our solution is submitted successfully. So let me again first I have showed this. I have this this value, this tree, means this tree root, here left child, the right child, and the left child and the right child. First I initialize a query with the value root node, and initialize the maximum value, maximum sum with the minus infinity result level, current level. Result level is our answer, we have to return it, and current level is to track at which level we are means we are present. Then we start a while loop. It runs until the query has the values, and we declare the two variables, level sum with the 0, level length is query dot length. Means level sum is the reset for every time. Like I am at this level, I just declare the sum 7 plus 0 7. If for next level, I again reset the level sum by 7 plus minus 8 minus 1. So for that perspective, means we have to reset it, and let level length is equal to query dot length. Means we because we have to get the sum of these value. If I say this 0 has the two nodes, let's say 1 and 2, these are the left and child nodes here. For this row I have two nodes, 7 and 0. For this level 3 nodes, I have 4 nodes, 7 minus 8 1 and 2. So for that issue, we have to take out the level length here, query dot length, because at the same time we are taking out from the element from the front side and push the value from the back side, because query has this property. Now for that issue, for that issue we have to track this level length. Means we just start a for loop. It runs until the level length. Level length here is the this node value, like here 2, here it is 4, and start the for loop. We take out the value from the front side of the query and increment this level sum by this value. And if that node has some left or right child, then we push them into the query, their values, and every time. If it is null, then skip it. After this for loop, entire for loop finish, like here I get the sum here, 7 plus 0, 7. After this whole for loop, I compare this level sum value with the maximum sum. I am tracking the maximum sum also, so I just compare with this value. If it is greater, then update the maximum sum value and also update the result level with the current level. And current level I just upgrade every time, current level plus plus. As I move down from one row to second row, then I just update, like here 1, then 2, then 3. And in last, when the queue length is empty, then return the result level and our solution is submitted. So here time complexity here is the big of n, and because we visit every node exactly one time, and n is the total number of node in the tree, so time complexity is big of n, and space complexity also big of n, because the queue hold nodes level by level. And so due to that issue, we have to space complexity big of n. So to summarize this, what we learned today, BFS visit a tree level by level using a queue, and we snapshot the queue.length because before the loop to isolate each level, and calculate the sum inside the loops and compare after the loop. This is the also a base a main point here, and track the level number with the simple counter by current level plus plus every time. And if this was your first time understanding BFS, drop a comment below. I will love to know. If this video helped you, please like it, subscribe to JDCodebase and share it with your friends. See you tomorrow at day 41.